Module 4, Lesson 12, Distributing Expressions. This is a follow-up of everything that we worked on last week. We are going to take it another little teeny tiny half step, but it's all pretty much the same thing. So we'll practice looking at equivalent expressions with models and just writing equivalent expressions. All right, let's take a look at number A. Opening exercise A. 2 groups of 5. Go. How are you going to draw 2 groups of 5? I have to do it. Some of you were still getting confused on your quiz, whether 5 groups of 2 is the same thing as 2 groups of 5, which is not. This is 2 groups of 5. So, 2 groups of 5. Making sure that your boxes are the same size because 5 is your constant. 5 and 5 are the same, so your boxes are the same size. Now create a model to show 2 groups of B. Remember, 2 groups of B can just be written as the term 2B. Gentlemen? Thank you. 2B. And remember, the coefficient, which is the number, always comes first. So show me 2 groups of B. Any questions so far? Oh, this common core stuff is hard. Oh my goodness.
I know, right? This is
mind-boggling. All right, let's continue. Now we're going to write an expression that's equivalent to 2 groups of A plus B. This is 2 groups of A plus B. So first, let's just show 1 group of A plus B. Now, should I draw my A and my B the same size? No, how come? Why do my A and B have to be different sizes?
Well, because A stands for a different number than B.
Right, A and B each represent a different value. That's not a constant, so they have to be different sizes. Does B have to be bigger?
No.
No, A could be bigger. Doesn't matter because we don't know. A could be 2 and B could be 1. We don't know that, so I would not mark it wrong if your B box was smaller than your A box. So now the expression 2 groups of A plus B tells us that we have 2 of the A plus B's. So let's create a model that shows 2 of them. Here's one, here's another. So draw that, God bless. So here we have A plus B, and here we have A plus B. So how many A's do you see?
2 A's.
Woo, how many B's do you see?
2.
So we have 2 A's and 2 B's. So how else could we write this?
Oh.
How else could we write this? Why don't we start by taking a model to show my 2 A's and my 2 B's. This is what the model would look like. So here are my 2 A's and here are my 2 B's. So now what's the expression?
2A plus 2B.
Yeah. So we can say 2 groups of A plus B equals 2 A's plus 2 B's. And that should be very familiar because that's exactly what you did on your homework for problem set 11. Right? Questions on where a 2 or an A or a picture or where anything came from? Not the question I was looking. Sure, but 4. Sure.
4.
But 4. See, I've got math on the brain. Sure.
Oh, good.
Okay. All right, moving on. Let's prove that they're equal. We can prove that they're equal by substituting A with a value and B with a value. Now, multiplying by 1 is so easy. So can I just make the A 1 and the B 1? Excuse me. Can I make, no, why not? Why can't I just make them both 1?
Because they're different, like, the variable stands between them.
Right, they're different variables, so they have to stand for different numbers. And because they're different values, that's why our boxes are different sizes. So let's write the two expressions. Two groups of A plus B. Write that down. You're in the middle of your page. Right below where it says this. Let A equal 3 and B equals 4. That's what you're looking for on your note paper. And below that, write two groups of A plus B. And next to it, write 2A plus 2B. And now let's replace everywhere we see A, we replace it with a 3. And everywhere we see a B, we replace it with a 4. Now here, 2A means what? 2 times A. So I can write 2 parentheses 3 because parentheses means multiplication. Or you could write it 2 times 4. I usually do parentheses when I'm doing this. I don't know why. But if you wrote it, you do that too, the parentheses? Yeah. But you can write it with the dot. They mean the same thing. So I wrote them both ways just to show you they're the same thing. So let's use PEMDAS to solve. Do the parentheses, and then we multiply. Here we're going to multiply first and then add. So are those two expressions equivalent? Does 14 equal 14?
I think so.
Yeah.
Yes. Not you think so. Yes, we just proved it. So when we double A plus B, we have 2 A's plus 2 B's. Okay, moving right along. So now we saw that when we doubled A plus B, we had two groups of A and 2 plus B. This is where I said we were going to take it to another step. Before we just had A plus B. But now look, we have terms now. We have a term with a coefficient 3x and we have 4y. So that's the only thing that's going to be different today. So if we want to double it, we want to write an expression that will double it. So before we write the expression, well, let's just write it here. How would we double that? Doubling is the same thing as?
Multiplying by 2.
Right, so I want two groups of 3x plus 4y. We want two groups of that. So that's the same thing as multiplying by 2. Now, is this a factored form, expanded form, or neither? Take a minute and think about what you did for part 2 on your homework last night. Part 2 on your homework, you had to find that common factor and write it outside the parentheses. And that's what we did last week with GCF. So we have the GCF, or that factor outside the parentheses. So this expression is in factored form. And you're writing that in your notes, gentlemen. So let's start this problem the same way we started the other one. So if we want to see two groups of 3x plus y, let's just start with one group of 3x plus 4y. Now be careful. A lot of people want to jump in and draw 3x's, but we don't have to. 3x is a term that we can keep together, and 4y is a term that we can keep together. So that's our model. Is everybody comfortable without drawing the 3x's? We can just say 3x, and we could say 4y.
But it's not wrong if you guys have to extra.
No, but let's just show the term that we have. So now we want to show two 3x plus 4y. So, all right, I need two of them. I don't know why the whole thing didn't come.
Because it's not.
It was working before. If I draw it all together, it should still go. So now we want 2 groups. Let's play the matchy-matchy game. Let's rearrange these so that we have our x's together, and so we have our y's together. So here I have a 3x, but I have 2 of them. And here I have a 4y, but I have 2 of them. So how many x's do I have all together? If I have a group of 3 x's here and a group of 3 x's here, how many x's do I have?
6 X's.
Yeah, isn't it easier just to draw it this way instead of drawing 6 x's? And how many y's do I have? 8 y's. That is a lot of y's.
That's a lot of Y's.
So what's an equivalent expression that we can use? So 2 groups of 3x. How many x's did we have? 6 x's. And if we had 2 groups of 4y, how many y's did we have? 8 y's. So that is your equivalent expression. So 2 groups of 3x plus 4y equals 6x plus 8y. So basically, what did we do? We took this number outside the parentheses, and what did we do with that number outside of the parentheses to the terms inside the parentheses? How can we explain what we just did? Yeah, so everything inside the parentheses we multiplied by the term on the outside. So let's write that. When there is a number outside the parentheses, this is like the bottom line. This is the point of the lesson. And I always spell parentheses incorrectly. But I spelled it correctly here. Because I cheated. I mean, I used my resources.
Better or worse for cheating?
So when there is a number outside the parentheses, I would multiply it by the terms inside the parentheses. Say the terms on the inside. That's a little bit easier. So when we multiply everything inside the parentheses by the term on the outside of the parentheses, it's nice we knew with doubling we multiplied it by 2. If we had to triple it, we'd multiply it by 3. But we're talking with variables. Sometimes we don't know what we're going to multiply it by. Suppose I have this expression here, 4x plus 5. So if I have 4x plus 5, but I don't want to double it, I don't want to triple it, I want y groups of it. Anybody want to guess how we would write that? Instead of doubling it and putting a 2 on the outside, instead of tripling it and putting a 3 on the outside, I want y groups of 4x plus 5. So what am I going to do? Yeah. We know how to read these symbols as words. Y groups of, parentheses means of means multiply, parentheses means multiply. So y groups of 4x plus 5. Any questions on how I wrote that expression from that model?
Not at all.
Now, we just finished writing that we could multiply everything inside the parentheses by that number on the outside of the parentheses. So how would I do y times 4x plus y times 5? Does everybody see what I did? I took that y and multiplied it by both terms. Anybody have a question? Where did the y, the 5, the 4x, where any of those things came from? Why the plus sign? Why the parentheses? Any of those questions? But that's like kind of a gross way to write it. We learned 2 weeks ago there's an easier way to write variables when we're multiplying. When we're using variables to multiply, do we even need symbols? Do we need the x? Do we need the dot? Do we need the parentheses? Or can we just combine them into one nice term? So how could I write y times 4x? Well, that would be y times 4 times x. We did that last week. That was on your quiz, too. How can I rewrite that in alphabetical order? How can I rewrite that in alphabetical order? In a new term.
4x4.
Yeah. 4 times x times y. Remember, we always write the coefficient number. We always write the coefficient first, and then we write the variables in alphabetical order. This was y times 5. How do I write y times 5? You did this on your quiz last week, and you did it well, I might add.
5y.
Yeah, plus 5y. The coefficient or number always comes first. Questions on where any of those letters came from? So we can summarize that y groups of 4x plus 5 equals 4xy plus 5y. All right, so that's a nice little summary of what we just worked on. All right, so now let's try it again. Write an expression. Woo, doesn't ask for a model. Just wants an expression that is equivalent. We just finished saying we can multiply everything inside the parentheses by that term on the outside of the parentheses. So what's 3 times 7d plus 3 times 4e? You could either use the dot or you could use the parentheses. It means the same thing. So what's 3 times 7d? How can we condense that?
21d.
And 3 times 4e, how can we condense that? No. That looks kind of odd, but it's quite not. I don't like those numbers and letters together. I don't know why. Yeah. Which is just numbers and letters, but I don't know. It hurts my eyes a little. Any questions on that? Yeah?
You have to add it.
No, we can't. Oh, good question. Good question. Anybody want to explain or take a guess why we can't add those? How come the answer is not 33 DE? Because this means 33 times D times E. Am I multiplying my D and my E? No, I'm adding them. So I cannot add those terms. Anybody want to know what those terms would have to have in common so I could add them? What would make those addable? They're not addable right now. They would not go together on Match.com. Why not? Why can't they?
Because they have variables.
Not that they have variables, they have different variables. So we can only add them when they have common variables. Logan, that was a great question. So since they don't have common variables, we can't add that. Not a match. Yep, they could be friends. They can hang out. All right. Try this one on your own. Now it's asking you for one to create a model for each expression. So how many models? Because I know that I have another equivalent expression to write. So how many models am I going to draw? I need 2 models and then the other expression. Go. All right, let's take a look. So first we need 3 groups of x plus y. Make sure that your x and your y are different sizes. Does it matter which one is larger? No. So 3 groups. Boys, this is not the first time I've had to ask you to stop being distracting. So here's a group of x plus y and my third group of x plus y. Now I'm going to draw a second model that rearranges it. So here is my x, but I have 3 of them. And then here's my y, but I have 3 of them. Now I have 3 of them. So if I look at what I have, here I have 3 x's plus I have 3 y's. Why can't I group them together into one big cluster of 6? Why can't I?
Because they're not multiplying.
Right. I can't add different variables.
Could you also put like 3x in a box and 3 on y box?
We could if that was the term we were starting with. Right now I'm just trying to model what I have. So my new expression would be 3x plus 3y. If you want to write them as equivalent expressions, and we multiplied everything inside the parentheses by that factor outside the parentheses. So write that down. So you asked about putting 3x in one box, and we can't because we started with a single x. My first term just had 1x, but then I got 3 of them by tripling it. Now look at the next example. My term is 2h. So since 2h is my term, I'm going to write 2h in that box. So I have 4 groups of 2h plus g. So go ahead and draw your 2 sets of models and your equivalent expression for this one. So my first group is 2h plus g. But I have 4 of them. So now I can regroup them so that I could see an equivalent expression. This isn't the best looking tape diagram, but you notice my tape diagram should both be the same size because they're both representing the same value. The total amount, my total quantity, what I have is still the same. It doesn't matter how I poorly draw it, they should still be the same quantity. So how many h's do I have here? I have 2 and 2 and 2 and 2. How many do I have?
Oh, sorry, 4.
How many?
Oh, 8.
I have 8 h's. And how many g's do I have? How many g's are here? 4 g's. So the other expression I could write is 8h plus 4g. So I think just for today, let's write the 2 expressions next to each other to illustrate that everything inside the parentheses was multiplied by that factor outside the parentheses. 4 times 2h is 8h, and 4 times g is 4g. Okay, before the bell rings, let's see how quickly we could write our answers. 8 times h is 8h. 8 times 3 is 24. Don't forget that second number. Everybody likes to forget that second number. Is everybody checking their work, please? Number 7. I have J groups of 7K plus 12M. Here, oh, look at number 8. 9AB plus 13A. Have a good day. There's extra help today.